Welcome to your deep dive. Today we're diving into the world of prime numbers. Those numbers have always seemed kind of mysterious, right? Like they've fascinated mathematicians forever.
It's true. Prime numbers really are like the building blocks of math. And when we unpack how we think about them, it actually reveals a lot about how we approach any kind of problem.
Okay, so I was reading this piece about prime numbers, and it started off talking about this idea of a perfect experiment. And I thought that was so interesting because, in a lab, you can't really have a perfect experiment, right?
Right, exactly. Even in the most carefully designed experiment, there's always going to be some margin of error, some variable you couldn't account for. But the author points out that's because of things like, the limitations of our instruments or the laws of physics, especially in the quantum world.
It's like we can't escape uncertainty, at least in the real world.
Exactly. But with math, it's a completely different story. Because math is a purely mental pursuit. It all happens in our minds.
Whoa, mind blown. Okay, so then the author poses this really interesting question. How many prime numbers are there? Smaller than any given number. And they suggest tackling this question with something they call a mental experiment.
Yeah.
So it's like we're imagining ourselves doing the math, right?
Precisely. And it's using the principles of the scientific method, but instead of applying those principles to the physical world, we're applying them to these really abstract mathematical concepts.
I love that. It's like taking the scientific method into the world of pure thought.
Yes. And this is where things start to get really cool. Because to even approach this mental experiment, to answer this seemingly simple question about prime numbers, well, we need to be really clear on what we mean by things. Our definitions have to be rock solid.
Okay, so it's like laying the groundwork, making sure we're all speaking the same language before we start building anything, right?
Absolutely. Even the most basic terms can have hidden depths, especially in mathematics.
Okay, so let's start with the basics. What about prime numbers? Before reading this, I thought I knew what a prime number was, but then the author breaks it down, and suddenly it's like, wait, there's more to this than I realized.
Amused. It's true. Prime numbers, though they seem simple on the surface, they really hold within them some really profound ideas.
Okay, so for those of us who maybe need a little refresher, how does the author define a prime number?
They define it as a whole number, and it has to be greater than 1. That can't be made by multiplying other whole numbers together.
Okay, that makes sense, but I'm already sensing a but coming.
Amused. Because now we've opened up a whole new can of worms. To really understand that definition, we need to define multiplying whole numbers. And guess what that leads to? We need to define adding whole numbers.
Whoa, so it's like this chain reaction.
Yeah.
One definition leading to another.
Exactly. And the author does such a brilliant job of showing how these really abstract mathematical concepts are actually rooted in fundamental human experiences. Like adding at its core is essentially just what we did as toddlers, grouping things together.
That's so cool. I'm already seeing math in a totally different light.
And it doesn't stop there. Remember that original question about how many prime numbers are smaller than a given number? Well, to tackle that, we need to be really clear on what we mean by smaller than.
Wait, there's more to it than just, one number being less than another.
You bet there is. And this is where that foundation we're building with these definitions becomes even more important. Because understanding smaller than actually goes back to that idea of adding whole numbers, of counting.
Okay, so now I'm really intrigued. It's like math is less about some inherent property of numbers and more about the sequence in which we encounter them, right?
You've got it. It's all about the order, the journey through the number line. But to really unpack that, we need to dive a little deeper.
Yeah, exactly. It comes down to that question of how do we even know one number is smaller than another? It's not just something we inherently know. It's like the author said, it goes back to that idea of adding whole numbers.
Yeah.
It's about counting. It's fascinating, really.
So it's not enough to just say, this number is smaller because it's less. We have to actually think about its place in the sequence of all numbers. We have to trace it back through that process of counting.
Exactly. And to get back to that original question that we were asking about prime numbers, how many prime numbers are there smaller than any given number? Well, to answer that, we kind of have to retrace the steps of counting. Like we're going back to the beginning and looking for all those prime numbers along the way. Okay, so it's like we're on a scavenger hunt through the number line.
Yeah.
And we're trying to pick up all the prime numbers we can find along the way.
Yeah. You got it. It's like sifting for prime numbers, right? And we can be certain that however many prime numbers we find, that number is going to be accurate because we're operating within this perfect realm of mathematics, as the author put it.
Wow, so it's like these prime numbers, They were always there, right? Hidden in plain sight. We just needed the right tools, the right definitions to actually uncover them. So are we going to actually try to do that? Like, are we going to try to find all the prime numbers?
Well, the author doesn't actually walk us through a specific method for doing that in this piece. They're more interested in the bigger picture here. They want us to see the framework, the principles that make such an experiment even possible in the first place.
Okay, so it's more about the why than the how at this point.
Yeah.
It's like we're building the rocket, but not actually launching it into space just yet.
Exactly. They're basically saying that because we've established these clear definitions, and because math operates in this perfect realm, well then, logically, a method for finding those primes must exist, even if we, in this moment, don't know all the intricacies of how to do it.
That's actually a really cool thought. To think that, like, I might not personally have all the answers, but just to trust that the system itself, the system of math, like, it holds the answers. It makes me think about all those mathematicians throughout history who were wrestling with these very same questions about prime numbers.
It speaks to this idea that math is cumulative, right? It's like each generation of mathematicians, they're building upon the discoveries of those who came before.
Yeah, it's like we're all part of this grand experiment, this ongoing conversation, each of us adding our own little piece to the puzzle. But you know me, I'm still curious about how those pieces fit together. And it makes me wonder, could we apply this idea of a perfect mental experiment, as the author called it, to something like history? History's always felt messier to me than math, like less about these absolute truths and more about interpretation and perspective and all of that.
Yeah, you're right. It is different. Like in history, we're dealing with incomplete information, right? And subjective viewpoints, biases that we might not even realize we have. So we can't control all the variables the way that we can in that perfect math experiment that we were talking about.
So does that mean, like, we can't have rigorous experiments at all in history, or is it just a different kind of rigor?
I don't think it's that we can't have rigor. It's just that we need to be more aware of the limitations. We might not be able to reach that same level of absolute certainty the way we can in math, but we can still aim for as much accuracy and objectivity as we can. It's like the author was saying about defining our terms, right? It matters even more when we're dealing with something as complex and messy as history.
Okay, that makes a lot of sense. It's about adapting our approach, right? Like playing by the rules of the game. But in history, the rules are just a little bit different. So we were talking about how to find prime numbers earlier. What's that look like in history when we can't control all the variables?
Well, instead of perfectly controlled variables, historians use things like primary source documents. They consider different perspectives. They look at things from multiple angles. And of course, they use logic and reasoning to draw conclusions based on the evidence that they find. So the better we understand the methods of history, the tools that historians use, the stronger our experiment becomes.
So it's like we're detectives, right? But instead of solving a crime, we're investigating the past.
Yeah, I like that analogy. And just like a detective, a good historian is always questioning, always searching for new evidence, and always open to revising their conclusions if new information comes to light.
This is what I love about these deep dives. We started with prime numbers, and now we're talking about, like, the nature of knowledge itself and how our approach changes depending on what we're exploring. So to bring it all back to our listener, what's like the big takeaway from this whole discussion?
I think the biggest thing is just not being afraid to question, even when it comes to things that seem really simple. Dig deeper, look for those hidden connections, and really embrace that journey of discovery.
Don't just take things at face value, right?
Exactly. And that kind of thinking, that's what makes us lifelong learners.
This deep dive has been amazing. We went from prime numbers to the foundations of math to the very nature of knowledge itself.
It's amazing how these things are all connected, right?
And for you listening out there, we'll leave you with this. If we can have those perfect experiments in the world of mathematics, where else in our lives can we apply that same rigor, that same pursuit of clarity? What would it look like to approach our own personal experiences, our own understanding of the world, with that same curiosity?
And those are some thought-provoking questions.
Thanks for joining us on this deep dive. Until next time.